Okay. Hello. Hello, everyone. Okay, I'm just seeing that there is something affecting the recording quality. I hope that you all can see me well. There is another problem in LeetCode that we need to solve today. Okay, I haven't solved it, I haven't read it before. Let's figure it out now. I just know that it's called open the lock. You have a lock in front of you with 4 circular wheels. Each wheel has 10 slots between 0 and 9, okay? The wheels can rotate freely and wrap around. For example, we can turn 9 to be 0 or 0 to be 9. Each move consists of turning one wheel one slot. The lock initially starts at 0, 0, 0, 0, a string representing the state of 4 wheels. So I think state is this. You're giving a list of dead ends. Okay, maybe I'm not giving the state. Okay, the state is always this, so we are not giving this. Dead ends. If the lock displays any of these codes, the wheels of the lock will stop turning and you will be unable to open it. Okay, interesting. So it will be a list of strings. And given a target representing the value of the wheels that will unlock the lock, return the minimum total number of turns required to open the lock, or -1 if it is impossible, given a target. So target is a string, and then the minimum total number of turns. So we are returning an integer. Cool, let's do some tests. So, let's say that we have target equal to 1, 1, 1, 1. And dead ends equal to empty list. So how many turns do we need to do to meet this value? Actually, it's only 4, right? Okay, cool. We basically need to move each of those from 0 to 1. Now let's say that we actually have a target of 2, 2, 2, 2. Maybe let's do this 2, 2, 2, 2 so that we can compare two scenarios. So here it will be 8, but let's say the target is 2, 2, 2, 2. But we have a dead end as 1, 1, 1, 1. So we are returning -1 if it's impossible. Here it is possible, but now we will need to rotate the other way around, right? So instead of rotating from 0 to 1, 2, we'll be rotating 0, 9, 8, etc., 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 until we get to 2 from the other side. So how many steps do we need to rotate? I think it's 8, so it's basically 10 minus 2. So here the correct answer will be 8 for each of those, so it will be 32 total rotations. Nice. Now let's look finally at this example. There we have dead ends as 1, 1, 1 and 9, 9, 9, 9. And here we are returning -1 because whichever direction we rotate, we will face the issue that it's not possible to rotate somewhere specific. Okay, this sounds good. Now the problem is with a very specific corner case, not like a corner case, but a specific scenario. So let's say, actually, Is this the case? Is this the case where we need to return -1? Because what if, for example, is it actually impossible? Meaning if log displays any of these clauses, the will log. So what I'm thinking, right? Let's get from 0, 0, 0 to 2 to 2 in this way. So first it's 0, 0, 0, then 0, 0, 0, 1, 0, 0, 0, 2, 0, 0, 1, 2, 0, 0, 2, 2, etc., etc. So we basically just increase these numbers until we get to 2, 2, 2, 2. So then the only problem that we have is that we have all of those. The only problem we would have, actually, this means that this is incorrect, and this is also incorrect, right? Because we are never displaying this particular thing or this particular thing in both of those cases. So it will still be 8. And the only problem appears, let's say that we have a target that is shorter, just to list all the possible dead ends. So if we have 1, 1, 1, 1, and we have dead ends that is equal to 0, 0, 0, 1, and 0, 1, 0, 0, 1, 0, and 0, 1, 0, 0, and 1, 0, 0, 0, then we will have to go the other way around. Will we, though? Actually, no, right? Oh, yeah, that's tricky. I thought that we would need to go all the other way around, but I think there is a shorter combination. So if we want to get from all zeros to all ones, we can do something like that. 2, and then 1, 2, and then 1, 2, and then this. So we basically make an additional step in this in the direction that is not the shortest one, and then we go back one step, and this will obviously be, okay, how many steps is that? 1, 2, 3, 4, 5, 6. So it will be 6 steps, which is still cheaper than going the other way around. Okay, now I have thought about this problem. Let's now think about this solution, possible solution. So one obvious observation here is that we only have 10,000 possible states. So if we have like 9,099, but it's pretty much 10,000. Oh, yeah, because we also have 0, 0, 0, it's exactly 10,000. What I'm trying to say is the space of states is limited, and if we can calculate the number of steps that we need to make to get to a specific state, to a specific target, then we can treat it as a dynamic programming problem, right? So basically, for each of the states, what is the minimum number of steps that we need to make to get to this state? And then, yeah, we can use dynamic programming with memorization. In this scenario, we will have to remember the minimum number of for each of the states, and we can do either dynamic programming forward or dynamic programming backwards. So either we do memorization with recursion, or we do some like filling of a table. I'm thinking about how I would structure this problem and how do we process dead ends. So if we encounter a dead end, then obviously it's like infinity of steps to get there. Yeah, I think so. Dynamic programming, there is 10,000 states, and we can do O of one lookup for each of the states once it's calculated, and only need to calculate once for each state. So we are trying to get to the zero, and one it's also kind of a graph problem. So when we are, let's say, here, right, what are the states, neighboring states to the state of 0002? It's all the states that have each of those values either as +1 or -1 for the current value, obviously mod by 10. So we will need to iterate over, let's say we start with a target and we define a dictionary where we store the distance to a particular state, and we start doing a depth first search, let's say. So does the depth first search work, or do we need to do breadth first search? It sounds like the breadth first search is better because we need to find the minimum number of steps, and depth first search can find a longer trajectory at first, so we will need to update it in later. But breadth first search will be exploring all of those trajectories in the same amount of time. Actually, do we even need dynamic programming here? If we are just exploring with breadth first search, yeah, we can just explore in breadth first search. And whenever the state is visited, we don't visit it again, so it will again be of 10,000. So let's say that the number of states is equal to n. We just do a breadth first search, and it will be of n runtime, and it will be of n space. Will it be of n space? How many possible states can we have in our queue at the same time? Yes, it like we extrapolate further and further and further, it might be it might grow to some big part of the whole number of states. So yes, it will be open space. In our double-ended queue, we will be storing many states. It's not just that we have some limited amount of steps, states that we are storing in our queue for breadth first search. Nice. Let's do the implementation then. Just to be clear, how we finish the breadth first search, as soon as we get, yeah, I think we can start exploring from zero in this case, like from zero state, and we start exploring, and once we get to the state, target state, we just return the number of steps. And if we cannot get to the target state, we just say that, okay, it's impossible to get there. Actually, I'm seeing that I have some chat messages. Write me if I'm wrong, but if the then, okay, let me read the question. This is kind of the first question that I'm getting in those streams. So write me if I'm wrong, but if the dead end calls are like 5, 4, 3, 2, do we only need to avoid achieving this number by not pulling it, by doing something like, yeah, just offsetting by what one number? Yes. Checking changes. I think what you're saying is correct. So basically, if you see here, right, let's say we have those dead ends, it looks like we just don't need to display those things. If log displays any of these codes, then the wheels of the log will stop turning. But if we don't display those, if we never show this particular code, then we are fine. So here, okay, I think target one-on-one, dead ends. Okay, yeah, here we cannot, we have actually shown this. I was wrong here. So I think the correct answer here is still doing like 9 rotations the other way around, so it will be 36 because we did display it here. So does it mean that there is a simpler solution? So currently I figured out a solution that is of n runtime. But if we can find oh, but no, 36 is also wrong in this case. We just need to rotate this one number the other way around. So we rotate this by 9 numbers to the other way, but these can be rotated just once. So it will be 9 plus 1 plus 1 plus 1. So it's 12. This is the best solution. So then the question becomes, what can we rotate, what can we not rotate, and in which directions, and if there is a straight path forward. But I think it eventually goes back to our depth or breadth first search, because we are exploring in all possible directions. And if we are blocked, we'll figure it out. I don't know, maybe there is a more clever, more elegant solution about how to do that, but since we just have 10,000 states, of 10,000 sounds like a reasonable running time, so I will first implement this approach and see how it goes. Okay, so let's say that total steps equal 0, and let's say, how do we want to do current state? I think let's store the current state equals 0, 0, 0, 0. It will be the easiest to do. And then we have dq, which will be the q, double-ended q of the current state. So now while dq, oh yeah, and we need to have visited. So visited will be just a set. Okay, I see there are some new messages. Okay, let's say I have another question from checking changes. Let's say the goal is 5432, right? Target is 5432, and then we have dead ends of this list of dead ends. Okay, so I think in this particular scenario, the solution is pretty straightforward. So you just go from 0, 0, 0 to 0, 1, 0, 0, and then from here, you have bypassed this dead end, right? And you just start increasing the numbers until you get to 5, 4, 3, 2. And in this scenario, you will get there in like 5 plus 4 plus 3 plus 2, which is 9, 12, 14, 14 turns. And other dead ends won't create any issues for us. We can also circumvent them like the same way that we have circumvented this issue. Okay. I hope I answered the question, but let me now implement the code. So while double-ended queue, we are doing the current state equals the queue pop left, and for range in length current state. Okay, let's say actually current state will be a list. We will be mutating this list. Yeah, I'm just trying to figure out what is the most elegant way to find all the possible next states. If I was doing this in NumPy, I would just create 8 vectors that I can add to this particular vector. But I think I will need to do something like for delta in +1, -1, and 1. So new state equals list of current state, and new state add for range. That was nice Python coding. For I in range, new state of I plus equal, no, we cannot do plus or equal because we need to do mod 10, will be new state I plus delta and mod 10. So, and we also need to do tuple of this thing. So if, no. Okay, this, and then new state equals tuple of new state. And if new state in dead ends continue, and then if it's in dead ends or new state in visited, then we continue. Else we add new state to visited, add new state, and we add it to our double-ended queue. So double-ended queue, append new state. Okay. Then we have created the way to traverse the whole thing, but I think what we need to do is, while the queue, yeah, I forgot another loop for this in range length of the queue. This will be iteration on this level of our breakfast stage, and here we will be steps, total steps plus or equal to 1, or So there is an obvious corner case that I'm thinking right now, 0, 0, 0, 0, and target, yeah, target basically is 0, 0, 0, 0. So in this scenario, we need to do 0 steps, right? So we need to be able to return 0. So here, the total steps will be -1. Total steps plus or equal to 1. And here in the current state, on the first iteration, it will be just 0, 0, 0, 0. If current, so I need to do this join current state is equal to target, then return total steps. Okay, this sounds good. And here we are returning -1. So if we have exhausted the whole queue that we had, we just return -1. Nice. So we can try to find this solution. Yeah, let's say this. We will need to do 12 steps. We will probably not be able to exhaust the whole trajectory, but it will be quite a lot actually, states to exhaust to find this final trajectory. So we won't be able to do that, but let's see what happens at some iterations, and let's see how it works. So first of all, we have double-ended queue that is 0, 0, 0, 0. And then obviously it's stored as a tuple, but I will simplify things. And this is empty. And while GQ, now total steps plus or equal to 1. And now total steps will become, let me update it here actually. So it will become 0 on the first iteration. And then for the whole double-ended queue that is just one element long right now, we will do the current state pop left, and this is removed. And if it actually is our target, we will be returning 0, which is exactly what we want to do. However, otherwise, we will start iterating over the indices, over 4 possible places to update, and then for all the for 2 ways of changing this. So all of those are not currently visited, and all of those need to be appended to our double-ended queue. So it will be first index, and it will be -1, right? So it will be 0, 9, 0, 0, 0. Then it will be 0, 1, 0, 0, 0. Then it will be 0, 9, 0, 0, 0, 1, 0, 0, 0, 0, 9, 0, 0, 0, 1, 0, and finally 0, 0, 0, 9, and 0, 0, 0, 1. So this is just the first iteration. Then we are expanding and expanding and expanding it further. And basically the correct path will be where we need to do those steps. Like from here, for example, we will go and add another one, and we will go and add another one. And here we will go to first to 9 and then continue iterating the other way around, and we will finally get to the one from the other way, and we will get to the solution that takes us just 12 steps. So on 12 iteration on this, but it will be 8 to the power of 12, which is a huge number. That will not be that huge because we are not revisiting the states. But yeah, I think it works. Let's check. Unknown network error. Okay. While LeetCode is loading for me. Is this C or C++? Young Lord is asking me. It's actually neither of those. It's just Python. your normal usual Python. Yeah, for some reason I was kicked out of LeetCode. Let me just log back in. Everything is working very slowly, so bear with me, please. I'm a human and I need to log in with Google. And yeah, finally I'm able to sequence item. Okay. Oh yeah, that's a minor issue, but still an issue. So we are using integers just because it's easier to iterate over states, but that means that here we will need to do string of I for I in current state. Let's check now. Okay, this is wrong, which is interesting, something that I didn't expect at all. So is the logic wrong or is the implementation wrong? Let's check. So we have target 0202. And I'm saying that output is 4 and expected is 6. So, that's interesting. Okay, so dead ends are these. And target is 0202. I think it means that, oh, yeah, the problem is that dead ends are not stored as tuples, so that's another problem. And okay, let's say, how are we going to store this visited new state? Okay, so if maybe let me actually extract this as a sub function, because why not? It's nice. Yeah, it's a static method for the class. Let's not care about this. Let's just make it a private method. String representation of state, which is a tuple of integers, and it returns a string. And here we will be returning string represent from for state. So now we have this nice function and we can use it in two places. First, we can use it here, self this of current state, and here if self of new state in dead ends. Okay, now let's update the solution. Obviously, I have forgotten self for a class. Let me add it here. Yep. Let's see if it works. Wrong answer. Oh, interesting, interesting. So that's a corner case that I didn't foresee. I just assumed, I should have been explicit about this, that 0000 cannot be a dead end. But that's pretty easy to guard against. If dead ends, if 0000 in dead ends, that's the only case that we are not processing, return -1. So the only scenario when we are doing this. And use test case. Okay. For some reason it's pending for a long time. Network error. Let's just try to submit it and hope that it does submit. Okay, judging. Okay, I see. So my solution is reasonable, but it's not optimal. So it's passing. But if there is a better solution possible, how do I figure that better solution out? So I'm visiting too many states that are not needed. So how do I make it faster? Let me see. There is also. Okay, there is a young lord asking me a question or commenting. I'm fresher university as a computer science student, currently learning programming through C++. And the last question I solved was to find rectangle sum inside the matrix. Yeah, sounds like a LeetCode problem, but to be honest, I don't remember this particular rectangle sum inside the matrix. Yeah, hope it worked well for you. Okay, let me think a little bit about how to approach this problem in a better way. So there is an optimal sequence of steps that we need to do. What I'm thinking about right now is whether we can figure out if there is a blocker. So, okay, this is actually interesting. We have 8 possible ways to get to those numbers, to get to any target. So what I mean by 8 possible ways, whatever is the target, let's say it's 5, 4, 3, 2, we can move either, for each of those digits, we will be moving either in one direction or another direction. Will there be a way when we need to start rotating in one direction and then rotate back? So let's say that that's something that I cannot figure out right now. But let's assume that we always need to rotate. Yeah, I actually can see, theoretically, let's say that we have everything in dead ends, all the possible combinations, except, let's say we are trying to get to 2, 2, 2, 2, 2, and we only have these combinations not in dead ends. 3, 2, 2, 2, and then 3. Yeah, everything everything between 0, 1, 0, 1, 2, 3. So what I want is, right, that we first need to get this to 3, and then we are moving all the other characters, all the other digits to 3 2s, and then we need to move back 3 from 3 to 2. So can it be this way? So yes, let's say that in our path, the only valid combinations are this and this and this and this. And then we have, once that's 3, so then everything that gets us between like 0 and 2 here. Or maybe let's actually simplify this. No, we cannot simplify this. Yeah, we need to have 2 steps to demonstrate what I'm trying to say. And then all the non-dead end combinations are like this: 3 0 0 1, 3 0 1 1, 3 1 1 1, 3 1 1 2, 3 1 2 2, 3 2 2 2, and now finally 2 2 2 2. So those are the only possible combinations that we have, and that means that we will have, the only way for us to get to this number is to first rotate this first digit to 3, or to whatever the number it is, and then move back 1 step to get back to 3 2 2 2 2. Because if we didn't do that first, then we would need to visit a dead end. So what I was initially thinking was that we never need to go back, and in such case we just need to figure out if there is a like of roadblock like we have here on a specific path. If there is such a roadblock, then we cannot do anything about it. If there is no such roadblock, then we can just rotate each of those digits independently in a specific direction. Yeah, the problem is that those 4 digits are obviously not independent. We cannot think about them as independent rotations, because if there is a specific value for 3 digits, then 4th digit can only also take maybe a specific value. Yeah, so for now I don't have an idea about how to solve this faster. So currently I'm solving this in O of n, where n is the number of states. I'm not visiting the same state twice ever, so it's faster this way. Is there a better solution? I cannot figure this out, because for now I see that we need to explore all the possible solutions. It's unclear how to do that, and it's unclear how to make this BFS faster, because we're always just making 1 step, and we cannot do some A star algorithm we also cannot do. So yeah, I don't know what's the better solution, but at least we have figured out the O of n one. And actually, yeah, depending on how you define the number of steps on this like n, it can be of it can be faster than O of n in general, or can it? Actually, it can, because any trajectory shouldn't take more than a specific number of rotations. So if we are doing more than a specific number of rotations, we are probably doing something wrong. And currently in my algorithm, we are exploring all the possible paths, all the possible rotations. Is there a quick way to remove some rotations from consideration? Yeah, there are some ways to prune. For example, if we have a roadblock in a particular direction, then we can just not consider this direction for rotations. But otherwise, yeah, it should be like the very clear roadblock like this. So basically, all neighboring numbers, all neighboring values should be inaccessible. Oh, actually, I think here it's also faster than 12, right? Because I think, yeah, here we have already encountered this. This is not 12, which this is 1, 2, 3, 4, 5, 6. 6. Yeah, I was thinking that maybe we can rotate one of those the other way, so we can start at 0, 0, 0, 9 and then do like 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, and oh, sorry, I meant 1, 1, 1, and 1, 1, 1, 1. So 0, 0, 0, 0, 0. So it's 1, 2, 3, 4, 5. Is it correct? No, it's not correct. Because it's 9, 9, 9, and I have lost this one of 0. Yeah, so we have to still make 6 steps, but we can also move the other direction 1 step. Yeah, and this was also an example of some specific. Oh, but this is not working. This is not working, but this one is working. Yeah. So we have figured out a 6-step solution. Yeah, okay. I don't know. I will review the solution itself, the tutorial. And for now, I'm stopping this recording. Thanks everyone for participating today. I got some chat questions. I probably should create some way for me to see those right away than when I'm getting those, but it was nice seeing someone here, and I will see you all